Service for Java developers. Now, this interesting topic like penetrating in the brains of the developer community about service mesh a couple of years ago. And I found myself in a situation, I didn't work at Kong at that time. I was also doing some work around another popular open source project called Apache Kafka. In that time, some of customers and users, they started asking questions, well, should I use Kafka with service mesh? And I was like, okay, so first of all, what is service mesh? Let me figure out what kind of problems we're solving there. Historically, systems that we develop in the Java community, we pretty much have like everything figured out, and we got covered from many aspects. If we need to figure out how to do load balancing in the big distributed systems, we usually have something that already doing this for us. Either it's a part of the system, for example, every distributed system, like a modern distributed NoSQL database, messaging system, and all these things, they already use this concept built in. So when you're using their clients, you don't need to write your own code. They use consistent hashing to figure out like how to find the nodes and things like that. And like, are we complicating things with the service mesh? That's why I have this picture. Like, it used to be so simple. Like, you running the one application in Java enterprise container. Obviously, you have a Java beans. It's must. It's requirement. You need to have a Java beans that run your business logic. Most likely, you will be running this on web logic or WebSphere. So you run this front end, you expose this front end using a thing called JSP. It's a kind of like a server-side templating engine that allows you to inject some of the stuff. And in the past, we used tables to do our layout, all the elements on the pages. It was much easier to do this like CSS and all this like web components and all this kind of stuff.
Two, pretty popular.
Which one?
Timeleaf.
Yes. Yes. So Timeleaf, it's like a XML-based templating engine, and it's much faster than GSP, for example. Like, they're doing a lot of stuff on optimizing the performance and things like that. But I'm talking like good old days, good old days. Struts, Wicked, this good old days, and database. So you think about this. Everything is kind of monolithical. Everything runs in one server or multiple, maybe on two servers, because probably you want to have database running somewhere else. So your application people will be handling this stuff for you. However, if you think about this, it's actually not that simple at all. So there was a technology that allows you to connect to the systems. For example, if you want to get connection to this database, you're using something called JNDI, which is Java naming and directory interface that allows to, someone will put something and you kind of request by name, hey, give me database connection, and your application server will give you database connection. Or you can rely on something like connection pooling in order to perform database resiliency, so you're not hitting with every request that comes from your web server, you're not hitting this directly to your database. So you're using this type of technology. So you already were doing this type of things. You already were relying on these things when you're running in this like application container. Things changed slightly in the world of containers. Definitely containers help to move the revolution of the microservices. Want to quote and rephrase James Gosling here. So it's not write once, run everywhere. It's a package once and run everywhere. The containers that allows us to run this. With the inception of the Docker and like year after Kubernetes for managing all these containers, this revolution and the adoption of microservices and APIs become a kind of like avalanche. So a lot about refactoring today. Refactoring to microservices, not like I'll take some of the concept of the monolithic application and refactor to microservice, but I will talk about some of the concepts that allows you to change the way how you should think about microservices. And the micro would be important part of this conversation. So let's do this. My name is Viktor Gamov. I work as a developer advocate at Kong, cloud connectivity company. Thanks, Sunny, for introduction of the company. So I talk to developers. Why Why I can talk about Java? Because I'm a Java champion. So last year I was also invited to join a group of remarkable people, people who use all their free time to evangelize Java. They not work for Oracle. Even like people who work for Oracle, they cannot be Java champions. So it's a community, great community, love Java. During pandemic, I finished the book in Java, all examples in Java about Kafka. So go check this out, called Kafka in Action. I think it's pretty good. All right. So let's get back to this concept. Application server runs our applications, our the WAR files, and our ER files. If you know, more unlucky or unfortunate. This is where we're gonna be dissecting things. So let's start from make it this like a look bigger. So let's start from the monolithic application. So this is our monolithic application. So big part of this application is actually like not gonna be maybe 100% involved any distributed communication. However, communication to database usually distributed. Usually communication happens through the network because in the past it was separation concerns and what we called like cross-cutting concerns as well, because database would be managed by a special trained group of people. They know how to do security, they know how to optimize indexes, they know how to do all the things in order to database run smoothly. And your application needs to just simply not do stupid things in order not to break your database in production. And essentially, the services can communicate to each other. Like one service can be in service in this particular case, it's just like a vague term. In this case, it can be application service, it can be API, it can be database, it can be messaging systems. Everything would be interact with each other through the network. Application servers like a web browser, the web servers and stuff like that. With the API-based communication, we actually switching from the invocation like a CPU-based computation into network-based computation. We go from the calling some interfaces, calling the methods of this into some sort of APIs. But in the world of monolithic application, we usually use our memory as our ways how we can communicate through the methods. And in the world of network, we're using protocols like TCP or HTTP in order to communicate. But there's other cross-cutting concerns that we usually, in the past, in the times of monolithic applications, we usually didn't take this into account. Things about who's going to be collecting decentralized logs. We can say, yeah, we can put this, we have this login configuration and everything will go into the console or in file. Or if someone needs to collect this and to move this into some system in order to store it and in order to analyze it in the future. How we can be dealing with security? How we can be responsible for have an encrypted connection between our database and our services. Usually developers don't think about this type of things. Either people will rely on this, which means people equals infrastructure, or we need to build in this in our application code. Same thing with all the other components that I mentioned here on these slides. In order to do observability, collect the metrics, we either need to include Java agent that will be collecting, instrument our code without changing the code, or we need to explicitly change the code to expose certain metrics. Frameworks like, so the metrics collection started in a drop wizard, and there was I forgot the name of the framework, but before all this micro method that became a standard in the Java world to collect the metrics, there was another framework that just slipped from my mind.
I think it was just drop wizard metrics, man.
Yeah.
That's why you're not wrong.
Yeah, so drop wizard metrics. Write down in the comments if you remember what I'm talking about. So there was one of the first microservices framework called drop wizard, and it include a lot of cool features that many developers inspired. And we're gonna talk a little bit about we're gonna be walking through the memory lane because some of the stuff that Drop Wizard did was influence other people like Netflix, and Netflix influenced people in the Spring to do things, whatever they did. and other things. So those things need to be built into your application. So these components, nothing to do with application code. Those components are nothing to do with business logic, nothing to do with the service that this microservice needs to do. And obviously, if we need to deal with the connection things, with the databases and the handling this gracefully, we can program this ourselves. Yeah, connection pooling, the technology that allows to cache some of the results on the distributed caching, that cache some of the results from the database, so if the database is not available, application still can continue to operate. Yeah.
Would you include things like rate limiting and traffic throttling in this list of like stuff that you have to hand code generally?
Yeah, exactly. I will. It's going to be like literal on the it's on the slide. Routing.
Routing.
Yeah.
Okay. Sure.
I'm gonna be calling names right now, like very soon.
Cool. Just curious.
Yeah. Essentially, we're going into the world of the microservice that when you need to do like a client-side like a load balancing in order to have a multiple instance of your application, you need to come with some framework that knows how to roll across different connections. So the Ribbon, one of the popular frameworks that was developed in Netflix and adopted by community, and now I think it's also part of the Spring Grid now. The Ribbon is the client-side technology that needs to connect to Eureka, which is discovery service that allows to get the access to the system. So Resilience 4J that allows you to build in like fallbacks and the circuit breakers into your application code, all handling all this situation, how you can deal with the services. So again, this Resilience 4J need to bring some centralized configuration stuff into the system in order to, the system to understand like how to communicate with other things. We're going to be using metrics. We also need to include these libraries, and we expose those metrics to Prometheus in order to Grafana to draw those metrics and all these kind of things. We already have like so many different the colorful squares with the rounded corners on this diagram. We basically polluting the microservice system with the thing, with the different things that just help to run services successfully. So the services will continue to run and continue to connect to other pieces. Obviously, API Gateway allows to bring the traffic from outside world and protect some of the the connections from your users who consume your API to this microservice. And also, API Gateway allows to route if the microservice is down, so it allows to route the microservice to another instance. So there's a lot of stuff going on here. In order to understand the microservices, API Gateway needs to have a discovery service in order to pick up where the service is coming from, and after that do kind of like a load balancing to the system. So a lot of things going on. And as a developer, you need to know a lot of things. So the only thing that we actually want to do here is just like implement business logic. So what if we take all these things that we built as a libraries, bear with me, like I explain why this slightly better than running this as part of library, and take this, extract this piece of functionality into separate process. It will be tiny process that will be running next to your application, and it will be handling all this, what we call cross-cutting concerns, all right? So, and this is where I want to focus my time for the next like 5-6 minutes and explain you like how this will change this infrastructure. As a matter of fact, this is not something that like I made up for this presentation in order to convince that microservice, the service mesh is the best thing for microservices. This is actually what the Twitter did. There is a service mesh called Linkerd that started as a framework in Twitter, as a Scala and Java framework. And the first generation of the service meshes actually were libraries that you built in your application. Those libraries were if you're running multiple services, you need to maintain different versions of these libraries. You need to maintain compatibility if you're running this across multiple different stacks. For example, if we're talking about Java, we kind of golden. But do not forget that there are some other people who want to develop services in our company, but they don't want to use Java. They want to use something else. They have good skills on the Go. They have good skills on the JavaScript. So, like, using Java library for them, it would be not something that they would be interested in. So, however, if they will be using this type of approach, so they will be focusing on this, on the same thing. They're writing these microservices, and the communications would be handled. All these cross-cutting concerns will be handled by this small thing called a proxy. And the communication between the services will become a communication between the proxies. Those proxies will have information about the circuit breakers, like how long I need to retry this particular service. If it's down, what I need to do. Or it has capabilities to just like immediately have an encrypted connection between the systems without you changing your application code every time you change certificates, for example. And this approach also works not only in microservices. This approach also works in monolithical world as well. So you can have, if you have a communication between the monolithic systems, it's one of the ways how we can start migrating monolithical applications into microservice world. Start by outsourcing some of the bits of that application does into the infrastructure that in this case is going to be this proxy thing. We definitely don't want to discriminate by the way where we're going to be deploying our stuff. Some of the service meshes that were developed, like for example Istio from day one, it was kind of like the Kubernetes first system. It's going to be only pods will be served here, and we're going to be focusing on this one. We want to run this across multiple different environments because people are running their workloads in the virtual machines, in the bare metal, and they're running this in all these containerized environments as well. So this is also an important part that this thing should be executed in the different environments. In the virtualized environments and where we can have a control over how we're going to pack our workloads, how we're going to be deploy them, we might have just like one instance per every service, and so in this case, the load balancing will be handling on this like a proxy side of thing. Now, it's a good thing that we have all these proxies. Now let's talk about the configuration. So configuration of this proxy, configuration of this thingy can be done very easy. We can go and change configuration file, and after that we'll commit this file, and our GitHub action will pick up this config, and after that deploy this across our services. That's one approach. But another approach, maybe we can use the API in order to configure those proxies, because we want to have this configuration fast. We want to change this the configuration for the proxies because we're adding more services, or we're scaling our services, or we kind of facing a data breach where we need to quickly reissue new certificates in order to reestablish secure connection between the systems. So configuration statically is good, but dynamic configuration is better. So in this case, there should be some configuration server that will handle this type of thing. So centralized service that, as you can see, it's not standing on the critical path, on the path of request. So configuration service exists, and the proxy servers will continue to do configuration. With this, essentially, we discovered, we invented the service mesh. So this is exactly what service mesh is. It is a thing called control plane that has information about topology of the system, and each component of the system runs together with small proxy that will be pumping the traffic that we call data plane. So essentially, the service mesh contains these two things. And control plane will be able to distribute the configuration, and when the control plane will be down, the system will continue to operate. Yes, it will continue to operate with some of the older data, but it will continue to operate. Like eventually, the control plane will be recovered, and it will be updating all this configuration on our data planes. But most importantly, think that if the control plane will be down, it will not affect overall system to be down as well. So it's not like in the service mesh we have centralized the failure point. No, it's not. It's not like that. Now, this concept can be scaled not only within one data center or like one region or one zone or whatever. This concept can be scaled into the multiple meshes. One mesh can be running in one data center, another mesh can be run in another data center, and through the control plane, we can have one global control plane that will span and will controlling over these all these meshes. And traffic can be controlled, like which services can communicate to services, because sometimes or many times we know that if we go in cross-region traffic, it usually will be cost more. So with the service mesh, we will be able to define the rules that will prevent some of the services to hit other services that will not. You cannot hit because of the geography and all these types of things. Now. Today I'm going to be talking about Kuma, which is a sandbox project that we developed at Kong, sandbox CNCF Cloud Native Compute Foundation sandbox project that we developed at Kong, and we donated it there. We do have a few few customers who use this in production. We talked about those last year in the Kong Summit. And we're going to be talking about this architecture using Kuma. So Kuma, it's a control plane. Basic component of service mesh that will be data plane will be relying on the known open source project called Envoy, and but a lot of things, a lot of APIs that we're getting in Kuma, we're getting for free from Envoy, like metrics, traffic encryption, all sorts of applying all different policies. But like secret sauce actually comes in the control plane. Control plane allows to good developer experience. So you'd not be, it's not going to be like a super convoluted with different configurations and the CRDs. And in order to move the communication between two services, we don't need to like spend much time like if we do in an Istio. And I think the idea of Kuma came from frustration of the other service meshes. So we were trying to build kind of no-nonsense control plane for service mesh. That's what we're trying to do with this with Kuma. Now, let's talk about the topic of today's presentation: how the Java developers can benefit. Usually, also like when I run my live streams, and if you happen to be on the Kong YouTube channel as well, kindly subscribe if you enjoy what you see, because usually like every 2 weeks we have this live stream show called Call Builders. We doing some stuff there. We'll playing around with technologies and talking about the cloud native technology as well. So today we're going to be talking about 2 Java microservices. And actually, the idea from these microservices came from my friend Ray Tsan. He used to be at Google. Now he's in Apple, and he's doing engineering stuff. So he's doing the real things right now. So not like a blah blah thing that we used to do. I like his approach for work ethic. And for work, he's going to work and sit on the meetings. That's what we do when we go into work. And we're going to be implementing this in the part of application. So there are going to be two microservices. One microservice will, when we call it, we will do some work. And what kind of work? We're going to be on the meetings. And what we're going to do on the meetings, at least, can I? Yeah, I can say this in this office because I'm not working in this office, so I work in remotely. That's the pleasure to work in remotely.
Only sleeping for 250 milliseconds during the meeting. That's it.
There will be multiple meetings, so I can sleep a little bit more. But for now, let me run this one meeting application. So essentially, it's going to be meeting application. We're going to run this. It's going to be Spring Boot application that has like a nice endpoint. Like I love Spring Boot because I can do this stuff like this. I can do ASCII art with the Kong logo. Love it. So things that Sunny also mentioned at the very beginning, that I also love this tool that we also developing here at Kong called Insomnia, that allows me to test all sorts of APIs. It's REST, gRPC, GraphQL, WebSockets are coming. So like one-stop shop for testing things. So if I will go to my meeting, I will send this request, and there's nothing in return because we're just sleeping here, right? So we just sleep for 1/4 of the second, but also we can see, So there's some useful information that comes from the request came from Insomnia, and I just like slept and kind of like doing the things. Next microservice will invoke my meeting service, and we will see what we're gonna do this. So the second one written using Micronaut Framework. It's also a pretty cool one. If you haven't tried this, highly recommend. The reason why I like this, the experience is very similar that I used to in the Spring world, though there's some of the discrepancies, differences. A couple things. So first of all, if you're a Spring user, you also can recognize this. I think the inspiration came from the Spring, how we call it, spiel. This Spring expression language that allows me to, using this meet.url, it's going to be environment variable that will be, if it's going to be specified explicitly, then use this. If not, it's going to be using this like a localhost 8080 as a placeholder. And I will just do a simple call using Java 9 HTTP client. Can we ask the question in the audience? Which version of Java are you currently running in production? So it would be a very interesting question to ask. Are you running Java in production right now? No. What are you doing in the Python? That's okay. It's also not bad language. So this is going to be like a request, and I'll do like 4 requests. So the response will get me 1 second to do like four meetings. So I'm go ahead and doing this meeting application, run this meeting application, stop and rerun. It's up and running, and when I do here, I just go in working application, I just go localhost/work. So add error because could not connect to the server. Why it is not? Why are you the way you are? So it is meeting application, but I'm running different one. Yep, sorry. Where's my work? I'm running different one. Yeah, work application, I'm sorry. That would be better. Yeah, Micronaut also has like the text-based ASCII art. I haven't figured out it yet how I can do the conch logo there, but if you know how you can do this, write down in the comments in the stream. So when I click here, it's going to be 4 requests going into my application. I will see this in the log of my meeting application because it will collect requests from user agent Java 9. Even though I'm running Java 17 right now, it is using a Java 9, where is that REST controller? Sets user agent Java 9 because this new HTTP client was introduced in Java 9. So that's instead of URL connection, you now can use the HTTP client built in your favorite Java platform, as long as you're running Java 9 or higher. So simple enough. 2 microservices. One microservice will do some work. Another microservice will do some meetings. Now, so let's deploy this into the Kubernetes world. To deploy this in the Kubernetes world, I already have my cluster prepared. My cluster. Let me do this one. So I'll show you my cluster. It's
everything from we're getting
everything in terms of answers. We're getting everything from Java 8 to Java 18. We got one person running Java 11, so
it's okay. At least there's no Java 5 and Java 6.
Yep. And those except for 18, those all sound like LTS, long-term support versions. So that's
so
good. Nice job, people.
This, Java 17, I'm running this right now. Okay, so running cluster of Kubernetes nodes in GCP, and so 1, 2, 3, 4, 5 nodes cluster. So in order to deploy these things, I have for my meeting. So, I forgot to mention. So only reason that I'm using Spring and using Micronaut here, two reasons. First reason is easy to build a web service, just put annotation, put some code, and it will handle some serialization, JSON transformation, so I don't need to worry all these kind of things. Second thing, both of these frameworks coming with the variety of tools that allow you to, for example, build a super optimized image for your application. So Spring Boot has built-in tooling based on build packs that allows you to have a super optimized layered image for your application. It will have a operating system, have a Java layer, they have a Spring framework version, and only on top of it, it will have your application code. So next time when you will be updating your application code and rebuilding your Docker image, the only thing that you're changing is the last layer, and you will produce new image. Similar things that happens in Micronaut. Micronaut actually provides a native version of application, meaning that there will be no Java at all. Spring native does the very similar thing. So those tools are amazing. If you having conversations and debates with some of the coworkers, can say, "Oh, Java is old and fat and big and things like that." Try the Graal VM, try the Spring Native. This is actually pretty cool. Like you can have just a few hundred of kilobytes. You can have a working JVM with web server, with database even. I did the episode of the KongHQ, which is also you can find in the Kong YouTube channel, with Josh Long, where we were chatting about the cloud native Java and how write this application that will be starting in the milliseconds. That will already include web server, that will include a database and stuff like that. So for this case, I have my images built in and pushed to my to Docker Hub. You can grab all these examples. Right, I'll show you from my GitHub, and you can play around with this as we speak. And I'll put the link on the. Come on. Okay, yeah. So that's gonna be a repository with all this code. You can play around and do it yourself. So with this, I'm going into here. So I'm using a tool called Scaffold, but you don't have to. You can do this like a Kubernetes, apply and go to a folder with all these Kubernetes manifests. Scaffold allows me to do kind of sort of like automation. If I'm deploying deployment and service, it will wait until deployment will be available, and after that deploy service. So in this case, there will be no race conditions and all these kind of things. So if I'll just do scaffolding, and it will check if there's something deployed, is already configured, waiting to deployment to stabilized. And if I go to my namespace where I deployed my application mesh for Java, it will bounce. I guess it's bounced the old versions of applications, and yeah. So we'll just like.
Are you deploying that to a local Kubernetes or like a GKE or something?
Yeah. So like. No, never doing the local stuff again. Everything is internets right now.
That's what I thought. Okay, I was just curious.
Like everything that I will be showing, like people from stream, they can do like hit directly and they will see the same result.
Sure.
Like YOLO.
Very cool.
Yeah. What could go wrong, right? So we just like deploying this live. So two applications deployed. Let's take a look. I'm using this tool called K9S to observe what's happening in my Kubernetes cluster. So we rolled the deployment. Some of the old things will disappear in a few seconds. And one of the things that if you ever use the Kubernetes, your workloads are not containers. Your workloads are pods. And pod is a collection of container. The easiest thing to remember what pod is remember Tide pods. Like if you visually have a Tide pod, you will see there's two things there. There's a green thing and the blue thing. So same thing with Kubernetes. As you can see here, I have a pod for meeting and for work. And one of these things there would be a container that contains my application code. Another container will contain something that we already discussed. It contains this small proxy, this data plane. So let's take a look on our meeting application. So There's a couple things here, more than one. We're not gonna look to init container, but we're gonna look to the things. This is our meeting application. How we know this is our meeting application? It has a Kong logo, and it runs application. So another thing we have here is the Sidecar. So Sidecar is the Kubernetes way how you can inject this local proxy. So when I was talking about this proxy, when I was talking about this guy, so this little fella, this little fella needs to be specifically small enough in order to perform the work, and the latency between this communication should be also minimum, because otherwise we're losing kind of all sense of having this proxy. If the proxy would be like a slow and cumbersome to use, there's no reason to rely on this technology. So in the world of Kubernetes, this particular pattern called Sidecar, and this is how we dealing with this. So this is a proxy. And why it is called Sidecar? In the world of Kubernetes, since it's the same pod, they have they're sharing network, they're sharing local host. So those containers can communicate through the local host. And what this init container does, so it actually changes the network rules. So all the traffic will go first to the Sidecar, and the Sidecar will be responsible for routing this traffic. So some of the things, if it's application code, it will Sidecar will route into my application container. Same thing for my work application. It's a Micronaut. And one of the things that we did this in deployment, we also injected this the meeting URL. Another thing that I have in my application, it's called Ingress, which is standard Kubernetes Ingress. Kubernetes uses Ingress in order to expose the HTTP-based workloads to outside world, meaning that from outside of the cluster. So if you go and hit this URL, you will be able to get the same result as I am. So for this, I'm using the Insomnia, and I'm going to this Ingress. It's going to be mesh for Java. .kong.me.sh, like kind of Kong mesh, Kong mesh. You got the idea. And when you go and try to hit this, slightly a little bit more, because the JVM was like warming up in order to sort of, but in general, we're getting around 1 second as a response, because we went for 4 meetings. So, and as a header, we can see that the Kong itself, I'm using Kong as an ingress controller for me, but it's like, we're not gonna talking about the Kong today. The latency that happens between between Ingress and my service, and my service responds in 1 second. We know why. Now, surprisingly, it works, because it's not supposed to, because one of the things that I did in my application, so first of all, we're breaking down this concept of service discovery. Since we have this dependency, we need to have this meeting URL injected somehow. Previously, I specified the service location and the port, and now I have this weird looking URL called meetings.mesh. So, where does it come from? So this is where our service mesh coming into the play. Viktor, you're showing us too much magic. How this happen? And it happens this very in a simple way. In Kubernetes, similar to Java, in order to provide some of the external functionality to some of the components, they use annotations. You annotate your namespace, like I annotated my namespace where I'm running my applications with special type of annotation called Kuma Sidecar Injection Enabled. What does it mean? So every namespace in Kubernetes that will have this annotation will be served by special controller that will be running inside of Kubernetes. And after that, it will be figured out that, okay, so looks like I need to inject Sidecar here. So this is how this magic happens. So you don't need to put this in your code at all. Now, you don't need to put this in your deployment manifests. You're not putting this in the code. So this injection, similar how we're doing this dependency injection with Spring, with dependency injection with Micronaut, very similar here, but instead of injecting beans, we're injecting containers. We're injecting containers that will be handling some of the communication for us. Where these containers are coming from? So containers coming from this this guy. So this control plane container and pod will be sitting there and listening every event that happens in Kubernetes cluster with regards to these special annotations. And after that, it will do the jazz. Now, so if I will go ahead and have a direct connection, so I will take this pod and will create the tunnel between this pod and my computer. So I will be able to communicate with some services that deployed here in my Kubernetes cluster. And specifically, I would be interested in this URL. So it's going to be localhost 5681 /GUI. So Kuma comes, so this is GUI from the Kong mesh, but it's based on Kuma, so it's essentially the same thing. Kuma has this UI that allows you to see what is going on with your service mesh. And one of the first things that you will see there when you just open this screen, you will see 1, 2, 3, 4 things that you are running here. So for example, it says you have 2 DP proxies online, meaning that 2 data plane proxies running. What does it mean? If we're going to drill down, we'll see 2 data plane proxies. One is for meeting and one is for work. So this is the same instances that we have in our namespace. Where's the meshes? This is data plane 1, and this is data plane 2. So those containers that running next to your application kind of like form a mesh. So we have a control plane with this UI, and we have two services that run in with with our application. So reason why this works comes with the configuration that we called a virtual outbound. So in the world of Kubernetes, there is a way how you can discover services. Once you have your application running as a part of deployment, and if the application requires the communication through the network, you will have something that's called a service that essentially would be kind of load balancer. So it's going to be Kubernetes provided load balancer that will be route all the traffic. If you hit this service with this particular port, it will route to this deployment. However, there's no IP addresses here, so the Kubernetes will handle all this like routing based on the names, and we don't need to provide IP addresses. Any particular moment of time, Kubernetes decide to reschedule all these pods in a different place, so IP address of the service will change. However, if you're connecting to the service, if you're trying to get the access to the service, this service will be routed to right IP address, correct IP address. Question?
It sounds a lot like Eureka.
Yep.
So is it a direct? It sounds like what's the directory? Is that built into Kubernetes, like the directory naming service?
Yeah. So this is the stuff like basically on DNS, and it's built in Kubernetes.
Cool.
Every service can be, if I go in this one, every service can have a name in the Kubernetes world and can be routed, and every service other can reach out to the service like my service. Next comes as a namespace, if it's our namespace called mesh for Java. And after that, it's called svc cluster.local. Like this is cluster-wide name that available for every service. So in our particular case, we have a name? Kind deployment, namespace, work. So it's gonna be work, and it's gonna be meeting. So I can put this in my, where is it? Where's my deployment, work deployment? I can put this here instead of value. Instead of value, I can put this like this. We can do HTTP, blah, blah, blah. 8080. But it's too long, right? So it's too long. And since they're running on the same namespace, you essentially can remove everything. So you can remove everything, and the discovery also will work. So this is something that you don't need external service. You already have this in Kubernetes built in. However, if we're going to be relying only on Kubernetes here, how we're going to be running this in our place? If we're going to be deploying our mesh in bare metal, there is no Kubernetes, so we need to deal with this. So that's why with the service mesh, we have this concept of virtual outbound that can define this special type of routing. So control plane not only controls and sending configuration to the different object inside the service mesh. Control plane also can be DNS server. So it will create special zone there, .mesh, and every service that will be joined with this service mesh will be able to communicate to other service using this .mesh URL. Also, every time it will be sending this to port 80. So, and after that, it will read the information from meeting. So meeting deployment in the service. It will read the information from the port of the service and will route. So every time while you're hitting meeting.mesh, it will be actually routing this to meeting.mesh for Java blah 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 port 8080. So this discovery is handled by DNS inside service mesh. Does it make sense or it doesn't? So the first thing.
Does. I just didn't realize Kubernetes provided that already. I mean, I should have figured, but...
Yeah, Kubernetes provides this, but the virtual outbound policy, this is something that comes with service mesh. This is even like a step further, and it's also not relying on the Kubernetes side of things. It also works in virtual machines, in the bare metal machines as well.
Sure.
Yeah.
Cool.
Okay. So, next thing, let's talk about observability and collecting all the metrics. So, Kuma service mesh comes with the
Viktor, before, just curious, you mentioned metrics a lot. Are you going to talk about logs too, or just metrics?
Yeah, metrics, logs, and traces going to be
awesome.
Coming up.
Cool, just checking.
Yeah, so we get this, the Kuma control, which is the CLI for controlling this. So I can get meshes, and I'll see what kind of meshes deployed there. So it's a default mesh, everything is turned off. Another cool thing about Kuma and Kong mesh, it has this kind of like a checklist when you first time start this and say, hey, you wanna check that you don't have all these things available. Those things are available to you, but you didn't activate this. So how about you go and activate observability, logging, and tracing things? It's like, okay, let's do this. So in order to simplify the things, Kuma control also comes with some of the cool things you can install. So first of all, the way how I install control plane, I just go download this Kuma control. After that, saying Kuma control, install control plane, and after that, it will just do the thing. I can install demo, it can install gateway, it can install metrics, logs, and blah, blah, blah. But I want to do observability. So in this case, one command will provision for me all observability tools, Grafana, Prometheus, Loki, Jaeger. It will create the scrapers for Prometheus, so the data will be collected, and all these things will be provisioned here in observability namespace. So it's bringing in. In order to activate this in the service mesh, again, like when you go to here, it will actually will send you to documentation, so you can go there. But I already have this configured in my code, so I will go ahead and uncomment some of the things that will be available. So I will be using Loki for logs. I will be using Prometheus for collecting metrics, and I will be using Jaeger for collecting traces. So how I can go about this? it is a standard Kubernetes CRD. So what I need to do here is just simply go and say kube control apply mesh mesh. So in this case, oops, it doesn't exist. And I'll go to mesh for Java. Anticipating the questions that I usually have about my terminal, it's a ZSH with tmux and some funny theme that I found on the internet. You can find this in .dot files in my GitHub. Usually people care about this much more than, come on, where is it? Like it's stuck.
I was curious about the little turtle that was running across your progress bar in your IDE, I have to admit, but we'll get to that later.
It used to be Mario. And I think it is still Mario. Like
It did look like Mario.
It
did look like a Mario themed turtle. I mean, my son plays a lot of,
Yeah, the classic game. You taught them well.
Yeah, I'm trying.
So it's called Mario. Mario progress bar. So it's exactly, it looks like the turtle and the Mario is running here. So yeah, it's pretty cool. It started as a Nyan cat, but they also have a Sonic. Where's the Nyan cat?
Nice.
Nyan cat.
Is this IntelliJ?
Yeah.
Yeah, of course it is. Yeah.
There should be Nyan cat.
Love it. That's great.
Yeah, the Nyan cat progress bar. So
perfect.
Yep.
That's a good
All right.
one.
So back to the fun part. So we install this. If I go to and refresh my screen, or I can do kube control get meshes. I will see that now this should be on. Why it is not? Didn't apply? Because I didn't apply this thing. So I'll just do kube control apply mesh. Yeah, didn't apply. Yeah. So now when I get meshes, I have this the metrics configured against the Prometheus, Loki against Loki, and Jaeger to this guy. So if I will go in my KNS and expose something like, where's the Grafana? Instead of creating the ingress, I'll just do local port forwarding that Kubernetes can do. So I can do localhost 3030. And it will ask me a few questions. Again, everything that you see here, you can try this yourself at home. It should work. It should work in local Kubernetes installation same way as I do. So we have so while I run this command kube control install observability, it also provisions some of the Grafana dashboards for the mesh. So I can go here and see nothing. Why? That's an interesting question. Thanks for asking. Took some time in order to disappear. So right now, this is information only from Grafana and some of the Prometheus servers. Why this happened? Because we also deployed this in an namespace where our sidecar injection it's supposed to be enabled. Why are you doing this to me? It's supposed to be enabled, but in my mesh for Java, okay, maybe it's like an old version, like the last 15 minutes. Let's 5 minutes. Let's say refresh. Where's this observability? It's supposed to be. It's not supposed to be here. Somehow it's here. But I don't see my services. I don't see my services here because in my services I didn't configure this traffic rules in order to collect all these traces. So if I go with my so this is a traffic log policy that allows me to capture all the traffic that comes from one service to another, like logs that happens within the communication of those two things. So let me apply those into Kubernetes cluster. Can I do that? Can I do this from my IntelliJ? Oh no, something's died. Okay, we'll do this from the console. I'll just do kube control apply mesh. And I will do traffic logs. So if I will go ahead and start hammering thing, and Insomnia can do this to me. For example, I can do repeat on interval. So instead of me doing this, I'll just do every 3 seconds. I'll continue to send the request to the server, and we'll get the response after 1 second. So this will suffice in order for us to do explore, discard, and we're gonna explore Loki, and we will just do app. What app we can do here? Work. So show logs. And now without me going into these containers, Loki start collecting all the logs that come in from the service, and I'm getting all these responses, and all these logs are collected from the beginning of the application. Also, we see here something interesting. So some of the responses are collected from the control plane. So information from from data plane, from the proxies also collected here from the log, because they're sharing the local host, and all these things will be captured here. For example, we can know that the GET request will be handled and things like that. Let's see if we will be able to get some traces.
And Viktor, you said the term data plane a few times.
Yes.
Are those the services themselves, or are those like? Could you just refresh my memory as to what you meant by that?
Yeah. So when we talk about this, by data plane, we call something that runs next to your service. Technically, simplify things, it is your service. Your next in the proxy that runs with your service.
Right.
This is data plane.
Got it.
And control plane that controls all these applications.
Yep. Thank you.
Yeah. Where we can see this in the UI, we can always see the data plane proxies, and we can see the standard data plane proxies, and those are running with the application. So this is what the Grafana come from and Prometheus come from. Now, if I go here, now I can capture traces. Again, by default, these things are not enabled, so I need to go ahead and enable these traffic traces. If you don't know how to do this, the Kuma UI will always lead to you, because there's always kind of check your mesh, and you can go and see in documentation how you can go and trace policies. But here, I already have this policy configured, and it looks like this. So essentially, now for every request will be captured and stored, and the data plane proxy will inject special headers to each request. And we will see this in the logs in a second, in order to collect these traces. So I'll just do mesh, traffic traces. It says unchanged, meaning that it's already enabled. Let's see, traffic traces. And the cool thing that we can always see this as on the UI, what kind of data planes are affected. Data plane proxies are affected. So those are here. This communication should be handled here. So let's see on the Jaeger here. Last 1 hour, so last 5 minutes. Bad request. It's a good time to check our Jaeger. Let's see, mesh observability, that's correct. Let's see, save and test. Data source is corrected, so it should be all right. Explore. Maybe it's because I'm running this in in intranets right now. There should be, no, where's my services? There should be, no, there should be my service should be here. My work service, yeah. It's a Jaeger, but where's my, let's see. A Kuma, let's see, save and test, it works, yep, okay, save and test. Let's see, explore. And we're going into Kuma and default mesh. Let's see mesh graph. Can we see this? For mesh default, for zoned not found, so just irrelevant, run query. 5 minutes. Here we go. This is finally we're getting to something interesting. So this is what our logic. So now with this graph, we will be able to see topology of our system, or like look in topologies of our system without doing anything, because we injected our data planes. Data planes data plane proxy will provide information. Prometheus will scrap this information, and we show this on the UI. So this is how the architects, Java architects, can do their jobs much easier. Just simply deploy their apps inside the service mesh, and they will have this architecture diagram for them built automatically. I did the talk where I was talking in service mesh in general. So I used the stuff that Google Cloud developer advocates develop. So they have this Google Cloud demo, like an internet shop. And I just took their stuff and ran in my service mesh, and it just worked because they have containers. I injected my data plane proxy there, and it just worked. So we're hitting one service. Insomnia continue to do these things. We're collecting this data. Now, let's do something funny. So I showed you how we can do routing with these, the virtual outbound, and have a kind of like a service discovery. I showed you how you can collect all these metrics and all this stuff. Let's see if I can show you some other things. So for example, control plane reports about health, and we can get all these metrics about the control plane and what kind of APIs were invoked. All these API were invoked from the UI. So UI itself always using APIs, and APIs also available to you to use. Next thing that I can do here, where is it? Discard? No. Browse. And I can do service to service. Yeah, for example, I can do service from, remember, we have a meeting service calling work service, right? So we got, or like work service calling meeting service. Work service calling a meeting service. And we're getting also information about the traffic, what kind of traffic codes. So let's stay on this UI, and we're gonna throw some of the cool things into the mix. Refresh, say every 10 seconds, last 15 minutes. That should be all right. Now, so service mesh allows control the traffic between the systems in a good way and also in a bad way. So let's do something in a bad way. So we can use this. We can use this service mesh in order to introduce this kind of like elements of chaos engineering into the play, and we inject faults into our requests. So what is going to happen here is that I will inject special traffic policy called false injection between services, between work and meeting. So every time once in the 2 times, it will throw error 500. And also I'm limiting the response bandwidth, but since they're running on one namespace, essentially they basically like close to each other. They don't think this will affect something. So 50% of the times we'll get the error 500. So let's see how this would look like. So if I'll just do conf mesh fault injection. So first of all, what we will start seeing in Insomnia. Now I'm going only on the 2 meetings, 3 meetings, because it's between 2 meetings, 0 meetings, because there was a fault injections there. So now I should be able to go here, just if I click refresh, where's my response codes, status codes. So all of a sudden I started like, it's scrolling here, it's scrolling like a small yellow dot, but it's coming. Let's do 5 minutes. To refresh. Yeah. So now it's slowly rate of 200 code going down, and rate of 500 errors coming here. So
green line was HTTP 200s.
Yes.
Yellow was 500 errors.
Yes.
Yeah. Okay.
So and we can go and again using the same tooling, just do localhost, and let's see what we see in the logs now. If I'll go to explore, I'm going to Loki, log browser app. Say where we were looking, we're hitting meeting, right? We're getting in the meetings. So show logs. So first of all, we start seeing special headers were attached to every request. So this has happened in order to tracing work. So application was not designed to be with traced, so your application doesn't know anything. So in this case, service mesh and the data plane proxy injected the headers to every request, so we will be able to investigate. Now, what else we can see here? So if I go into my work application, oops, and query history. Where is it? Run query, and not 1 hour, just 5 minutes should be all right. And there should be some 500 errors in the logs as well. So yep, so those are starting getting the 500 errors, but those are not coming from our service. Those are coming from our data plane proxy. So with enabling this type of functionality into your tool belt, you can enable the chaos engineering type of thing and see how your application will behave. So in our case, we're not handling. Let me show you. If I go to meeting application, not the meeting, sorry, it's going to be work. Work application, where's my controller? In my work application, I'm actually ignoring anything if the response will be not HTTP 200, so I will be increasing count. But in this case, I can also integrate some of the responses for errors 500. So that's something that my code doesn't do, but your code can. Another interesting thing that you can do here, I think that's going to be a last thing, is that that's the kind of introduce a retry. If the service will be, actually, they can work together. So false injection and retries allow to be more resilient for this type of failures. It has 5 retries and retriable source code. So in case of 500, it will retry. And my application code might not even notice this because I don't have this built in on my application. So let's try to do this. If I'll just do enable. It will take a little bit longer, I guess. It should do it more. So now I guess the responses are going through retry policy now. And now I'm not going into any meetings. Let me see. Yeah, I guess interval per 200, max interval 1 second, back off 1 second. Yeah, it should that should help. But anyway, I think I broke the application. Okay, that's fine. That happens. Kubernetes delete retry policies in retry schema. Where is it? The web. Oh, it has a by default. Okay, so it looks like it has a default policies for retry all. If I go here, retry all, and what it does, let's see, retry all. It's a built-in policy, and it looks like it's affected the all this. So by default, it's already enabled some of the retry. So let me remove my thing. So it's easy to mix up with the things very quickly. Let's delete this. And everything is happening in real time. So I'm not changing application code. I'm not changing. Okay, so now I'm start going to meetings. And if I will just do delete fault injection and fail 50%.
But Viktor, to your point, it's important for any infrastructure that you take a dependency on, right? You need to understand how it works. So if retries are happening under the covers, don't account for that, right? Or account for, or realize that it's going on and account for it differently in your application code.
Yeah.
So, like any infrastructure you decide to depend on, you need to know how it works.
Traces, metrics, and logs allow you to investigate this type of things. So I did again, on the YouTube channel, I did the video where I showed how to use the service mesh capabilities and all these observability tools to investigate. So, for example, we can, in the logs, so when we're going into logs, we should be able to, let's get back to Jaeger and see if we can be, we can get the, why I don't see it? It's like, Jaeger is probably broken on my side, but I should be able to see the service, and after that extract the trace ID, and by trace ID I will be able to identify where in the log things happen. So if I would know like error on the log, I can also trace back and see like where exactly the error happened. So always have observability tools built in that allows you to investigate, because you can, not always you will be able to attach debugger to your Kubernetes cluster in order to get the access to these type of things. All right, so that was part of the demo that I wanted to show. Again, you're watching us in, hopefully you're watching us and still watching us on YouTube. And this is where we're running some of the streams and talking about technologies like Service Mesh, API Gateway, Kubernetes. I'm a huge fan of Kubernetes. I like to talk about the Kubernetes ingresses, and I show in like different ways how you can use like exposing different services.
Victor, one comment from the YouTube. Someone was saying they use Loki for work and they need to, kind of learn more about it. Is that something you can speak to briefly?
Yeah. So Loki, it is a tool that comes from creators of Grafana. It's one of the things that we have built-in capabilities, built-in deployment instructions. But also, if you are not using Loki, we also support different. We have a Logstash. If we can ship logs there. Last year at the Kong Summit, I did a presentation with my friend Ricardo from Elastic. We showed how you can enable this type of functionality and ship these logs to Elasticsearch, and using whatever technology they use to investigate those logs. So Loki is one of the tools that like available and it's quite popular these days. And they work together with Grafana. They work together with Prometheus and all the things. Just people using this. It turns to be kind of like a go-to stack for observability tools for logs. Yes.
Going back to the slides where you show the proxy and the control plane.
Yep.
I'm curious when that one container scale up from 1 to 10, and the service itself changes, and the configuration for that one particular service change, how that change will be able to replicate to all the containers.
So it will have, when we're talking about in Kubernetes particular, right? So if, are you talking about deployment and changing replication factor on deployment?
And what's the second question you said?
So when you said like when we scale, is it we just change a replication factor on deployment in Kubernetes? So the things like, for example, if I go and do stuff like, we can go into, come on. Say I'm in mesh here. I'll just go deploy, and I just do replicas 2, like this. So in this case, we'll have another pod, and the data plane proxy will be injected in this pod. It will just have a different name. So it will, you see? So right now I created another replica for this, running the same instance of application. Access to this application would be on the kind of like a round robin fashion. So if I will go here and show you headers, I don't think I'm exposing this information for what I scaled. I scaled meeting. There should be. Yeah, so essentially the access will happen on a round robin, but this is going to be handled by Kubernetes service. It's nothing to do with the service mesh there here. So we have a service, Kubernetes service. And now this service backed by deployment that has 2 replicas.
Right.
And when we're hitting this service, Kubernetes will route the round robin to first the replica 1, replica 2, replica 1, replica 2, replica 1, replica 2.
So it's handled by Kubernetes.
Yes.
services, I see.
Yeah.
If the control plane is down, how do we ensure that the proxies for the data plane is still accurate?
Can you repeat your question once again?
If the control plane is down,
Yeah.
how do we ensure that the proxies for individual services within the data plane is still representative, the most latest state?
You can't, like, whatever configuration will be shipped there, it will be there until control plane will be, restart, and we'll check the latest configuration, new configuration, all these kind of things. So the control plane will be handling these things. Let's see. Actually, I think there should be something in every time when we go, we can always see. Let's see here. There's always XDS configuration. That's the something that each data plane has from control plane. So for each data plane, we can go and check this configuration. And this probably, let's see, if I copy to clipboard and go into, should use scratch file, JSON. No, it's JSON or it's YAML, it's JSON. So it's a big one. There probably should be somewhere like a version or something like that. Let's see. Object. Last updated. There's a last updated date. Yeah. So each configuration has this like a version info for all this configuration. So probably based on this hash, this is the version of the configuration that currently deployed on the data plane. When the control plane will be recovered, get this information about version. If it is different, it will ship new configuration there. So that's how I think it should work. But I need to talk to my engineers, and they will tell specific. But this is how I would check this. If configuration that I have on the control plane is different from the data plane based on certain version, and looks like the version would be behind, so I need to update this and provide new configuration.
If the control plane was down, you probably wouldn't be updating.
Yeah, but like when it restarted, and when you restart control plane and trying to apply new configuration, control plane needs to go and figure out like whoever has.
Who's got what version.
Yeah, exactly.
Cool. I like the test harness, the Insomnia thing that you were showing. It reminds me a lot of like Swagger and Postman. That's cool. I didn't know that.
Yeah, so Insomnia has the capabilities to do like open API stuff, similar to Swagger, I just like this one, the other one.
What's the if I remember correctly, is it Envoy that is? Excuse me, is it Istio that's kind of the control plane for Envoy? Is that okay?
The Envoy, it's a kind of like our working horses.
Yeah.
Pretty much.
Those are your actual API gateways, right?
Yes.
Yeah. Okay.
So the Istio, Kuma, and a few others, they use Envoy as a control plane. Mm-hmm. Linkerd, they use something that like handwritten.
Sure.
They develop something using Rust. But it's difference between Envoy. It's a general purpose proxy that's happened to be light enough to use in the concept of service mesh.
Yep.
Whereas, like, for example, people asking, like, why you can use Kong there? So Kong is also proxy. Kong also can be used here, but Kong serves like a bigger role as being kind of like a gateway for all the traffic. So there's some of the things in order to Kong to work. There's different plugins that's there. Kong potentially can be a proxy, but it's slightly bigger than
Understood.
Particular case. Also, the Kong also has this, some of the things that I probably will be talking on the Kong Summit is that what API gateways can learn from service meshes, because the concept of proxy as a service mesh learn from API gateway, but what can be done in an opposite way. So I want to talk a little bit about like a control plane and data plane architecture and how it can be also applied to gateway, whereas you can deploy your gateway on the edge where your traffic will go through, and the control plane can be deployed and manage multiple data planes. So there's tons of different technologies that are available there suitable for certain cases. Envoy was chosen by Istio at the very beginning. Also, we choose this ourselves. Linkerd using their own like a purposely built thing. It's not general purpose. You cannot just take this and start using this for your proxy thing. One of the things that people in Kubernetes and cloud native community doing for Envoy, they're building a API gateway. Like, there's a gateway API in Kubernetes. Sorry, the naming is hard. Gateway API is a new specification that comes in Kubernetes, and they will be using this like Envoy to build the kind of reference implementation for this. So there's lots of going on and lots of cool stuff is happening.
All right, great. Well, Viktor, thank you very, very much, and appreciate it. And yeah, if there are no more questions, I think we can call it, and wish everyone a good evening.
All right, cool. My name is Viktor Gamov, and as always, have a nice day.